So, well, let's start with the concept of a class. Okay, what's a class and why do we use those? Now, in the context of this lecture, we are not going to use structs as much as possible. It's not the structs are not useful, but sometimes they can have some use cases. But as the center of our attention, the classes would be on the table for this lecture. So whenever we want to pack something together, we are going to use classes in order to do this. So let's try to understand with an example why it is good to use something like a class. Okay, so imagine that you are somehow collecting some kind of a grades and names or IDs of some students. So what would you do? The first thing that might came into mind is to initialize two arrays. So the first array will be holding up the student names. So you can do it like this. So this is an array of strings. So let's say that we have some predetermined number of students, let's say 10, and you would have an array of numbers, which are grades, maybe. So you would have another array of 10 grades. And imagine that you are collecting those via user input. Now, I'm not going to implement this in full. I'm just trying to give you an idea because I don't want to spend a lot of time on that one. But you see, in here, when we collect those in some kind of a C-in-ish manner, all right? You can imagine the rest. Well, we can actually do something over the grades of each student somehow. So for instance, let's say you have collected the grades over 15 and you want to normalize them to 100. So you do want to do something on the grades. So making the link between each student name and the grade is not explicitly present in here, right? Because if you want to find the grade of a student, you need to rely on the intuition that both the student name and the student grade will be in the same index in this array. Okay, so how do you know a grade belongs to a student? So if the student's index is 5, then you know. So let's suppose that I'm outputting those. Okay, so the grade is, then I know that the grade 5 holds the grade of the student. Well, object-oriented programming is a large concept, and you are going to, maybe you already did, but you are going to get the course for object-oriented programming, and you will in detail discuss why classes are useful. They do have a lot of, there are a lot of interesting reasons in order to use a class, but this one is one of these reasons. So instead of relying on the intuition that both the student name and the grade lies in the same index in those two arrays, which is very easy to mess up, why don't we pack those two into something like a user-defined data type? Okay, so I would say now I have my own definition of a data type, and it's going to have some subfields, sub-data, which I would like to somehow access, and I want to define some kind of structure for that. So this is something which we call abstract data structure, And how we do this abstract data structure is, you can use a struct in order to do that, but we are going to use classes. And how do you define a class is you use the class keyword. You already probably know this from your programming course, BLG 102. So what you do is you give a name to the class student, And what you do is you just define it, well, like this. Now, and you put in the string name and integer grade in here, so that now when you want to define a student, instead of relying on the arrays, blah, 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 and now you can do, I have got a student array of students 10, and then you can do like students 5 name and students 5 grade, right? This is what you do. So what did you do? You packed those two data information together and put them in a new abstract, normally non-existent data type called student. So this is called, in object-oriented world, encapsulation. You encapsulate, okay, these two pieces of data into one single piece of data. And the C++ handles this just like it does over an array. It's in the memory, puts those two values concatenatedly. So one of them comes right after the other in the memory. Okay. So there's also something which is called information hiding in the object-oriented domain. So this one deals with actually hiding some of the values, data, from the outside world, because there might be a lot of different reasons in order for you to do that. One of the reasons might be you want to control how these data are set and get. So, for instance, if I do it like this, let me show you one example. I hope it works. So here is a student. Let me define a student like this. And let me set the name of the student to Tolga. And let me set the grade of the student to 90. Okay. And let me write the student name and grades. So normally what would you do is you would use a struct to do that. I don't know if I can do this, but let me, now please do not just ignore the last thing that I have written. I'm going to explain it to you. All right. So let me run this. So you see, I have written Tolga Doksan on the screen. But what if I say I want to give -90 to Tolga? That might be pretty much possible or impossible. Okay, I might be ruining my data by giving a negative grade to the student, right? So what I want to do is I want to be able to control how this data assignment is done by wrapping those values with a function, wrapping around those values with a function. But at the same time, I want the outer world to not be able to change those values in here. So what do I do in order to do this is I declare those as private. So when I declare those as private, I would no longer be able to make an assignment to those. So now if I want to run this one, it's going to tell me, ba-bam, compiler errors. You cannot do this because these are private. So what I need to do is I need to write some methods in order to be able to set those. So now I would have written something like set grade kind of thing. And I would want to take an integer grade. Okay, so this is just a definition of the function. And this function is actually called a method. When you write a function inside a class, this is called a method. and it's inside the public visibility, so everybody can call it. Now what I will do is I will write the student setGrade function, and I will put the integer grades in it. It's great. And what I will do is I will say the grade equals sgrades. Okay, of course I need to have a return value. All right. So what did I do wrong? Anyways, so let me now get rid of that one, and let me get rid of that one just for now. Okay, so instead of calling the grade, I need to call the function, and I will say set grade 90. Okay, and of course I still cannot access this, so I need to write something like integer gets grade as well. And let me do this like integer. I don't have any function parameters, and I would say return grade. All right, I hope I have done everything right. So.
Hocam fonksiyonun ismini değiştirmediniz.
Yes, I didn't. Thank you. So let me see if that works. There's an error. Let me check what's it. Oh, what did I do wrong?
Parantez yok galiba main'in içinde fonksiyon çağırırken.
Really? Oh yeah. All right. Let's go. Yeah. Now that works. Okay. Now that I can set it and get the value of it, but still you might be saying, so what? So what has changed? This has changed. Now, when I'm making the assignment, I can easily control and say if grade is smaller than 100, then I'm going to, s grade is smaller than 100, then I'm going to say grade equals 0. So I can do a lot of different things like this. So I can do like, if that's the case, I'm throwing an exception. If that's the case, I am giving negative feedback, so please re-enter, it's not valid, so on and so forth. So the thing is, now that's why we call that information hiding. We hide a direct access to the data, a piece of data inside my class, okay? And we make the information hiding. We write some methods like this, and we use them like this in here. All right. So, well, you can also write some methods concerning the name parameter as well, and this is perfectly fine. And these are called methods, and probably you are careful enough to see that when I'm declaring my methods, I do declare them like the class name plus 2 columns, and then the rest is almost the same with the normal function definition, and that's perfectly okay. Okay, you can do it like this.
By the way, sir, we don't have to use private for private variables.
Yes, but it's better if you write them still. So I like it better that way.
Okay.
Right. So if you don't want, you don't write it. But I think this is more structured. So.
Okay.
And actually, I think there is a slight difference if you don't write private as well. I'm not sure of it. Anyways, I won't be angry with you if you don't write private. Okay. So, all right. What's next is the distinction between a class and an object. I would like to name the names. So when you define the classes member variables and methods like this, these are the definition of the class. So including the method definitions as well. So it's like the usual programming. Whenever you define something, the value is distinct from the definition. So whenever you have an integer x, you might assign many different values to this x, but the x itself, its definition is fixed. X is an integer. And just like it, this student's now definition is here, and it's fixed. It's the code written in C++, and the class is this definition. On the other hand, when you instantiate, which means give value to a variable of type student, then this is called an object. So you can think of this like when I tell you to think of a playing card, okay, just like you play in Batak or Bridge or King, you directly think of something. Probably everybody thought of a different object, but everybody has the same definition. What a playing card has is it has a suit and it has a face. The suit is either diamonds, spades, so on and so forth. The face is, it can be an ace, king, queen, 2, 3, 4, 5, 6, okay. You know, so the definition gives you the abstract way to think about this real life entity. The object, on the other hand, is a runtime entity. It's the instantiation of this definition. So here, a student is an object. And this object in C++, there are two different ways to handle this object, create this object. One of them is just creating it by value. So this is a student as a value. Whenever you want to reach a student's methods, you put a dot and you write the method name, and you make it means that you make the function call. And on the other hand, you can also use pointers in order to represent a student with a reference. And it works exactly like the arrays, okay? So you have got a memory address of the object, which is instantiated in the memory. And you need to, of course, instantiate it. Like what? Like calling new. Okay, but there's a slight difference when you use pointers. When you use a pointer instead of a value, you need to use a different operator. And this operator is, instead of a dot, you need to use this arrow. Okay, set grade, get grade. You see, they are exactly right here. So if you do this and say, all right, I am using a pointer, you need to use this operator. Now, this is just like the last lecture that we have talked about. This is just a syntactical shortcut, and it means this. Okay, so using an arrow is the same with this one. First, the referencing, and then using the point notation over the object. Instead of doing this, you can directly use the arrow notation, and it is going to first the reference and then make this function call. Okay? And of course, whenever you use a pointer to an object, you need to initialize it with new and deinitialize it, destruct it with delete. Okay? Let's see if that works. Of course, I forgot to make the change on this one. Whoa. All right, there you go. But I was still able to set the grade to, oh, I made a mistake in here. I made a, this code is not right. Still, why doesn't, oh, why doesn't it work? Let's make a debug and see what's going on there. Okay, now I had a grade, S grade smaller than 0. Oh, very foolish mistake. All right, now it should work correctly. Yeah, now it works. All right, I hope you got what I am trying to do. So this is a very basic way to code an object, a class and an object. And now if you look at this, even with the small example, there are some fields which needs to be instantiated at the moment that we create an object. Okay, so it's according to how you define your class. It might be required, it might not be required, but you sometimes want to be able to instantiate an object only if there is some pieces of information present at the creation time. So in that case, what you do is you write a constructor, something which is called a constructor. Actually, even if you do not write it, the constructor is there, but you can rewrite it and modify it according to your needs. So how a constructor is written is you do not provide any return value because the constructor constructs the object of the class and returns the object of the class. So you don't write a return value, and what you write is a function name with the same name of the class. Okay, so this is the function name. Now let me write student. Okay, now let me put some hello from student here. Okay, and let me run this. So you see there's a hello from student, because whenever you are making an initialization, this constructor is called. So it doesn't matter if you do this over a pointer or not. This constructor is always called when you are initializing a class. So what? So this. Now I want to initialize the student with its name. Okay. I can write this constructor according to my needs. String name. Let me call this a name or s name. Okay. And let me do this name equals s name. All right, and let me write this one as, let me put an get name as well. All right, and let me put here student get name and return name. Okay, and let me write it like get name, and let's see what's going to happen. Oh, I got an error. What is the error?
Hocam klasın içinde ismi koymadık sanırım. Name'i.
Really?
Constructor.
Yes. You're right. Yeah. Now I've done that. I set the name to Tolga. How did I do this? I have declared a constructor which is taking a parameter, and in here my constructor gets this parameter and assigns it to the name of the student. Okay, so you see I'm going to dig into this in a few moments, but you see there is some kind of a scope in here. When I say name, even if this function doesn't have a definition of a name, declaration of a name, it directly uses this name inside the class student. Okay, so, and once I do this, when I say new student, I need to send a parameter as the name of the student, and it is directly written inside this name of mine. Okay, so sometimes you might want to do something like this, which is pretty, which I believe increases the readability of the code that you are writing. Instead of using a different value, different variable name in here, you might want to choose the same variable name with this. But now this is something weird. Name equals name. So what does this one refer to? So if you have a local variable coming from your parameter, this one is used instead of this one all the time. But there is a way to get over that, get behind
I think
that.
is this as a pointer and name, right?
Yeah, I was about to say this. So there is a way to get beyond that. So since you have a string name in here, in the scope, always this string name is used. This is not used if you have something like this in here. So in order to refer to this variable, you can use some special reference, which is always inside any object, which is called this. Okay, so this is a pointer to whichever object that you are using. So whichever object that you have, if you say this inside that object, then you are referring to whichever object you are calling it from. Okay, so this is a little bit mind confusing because when you say this, you are doing it inside the class definition, but this is instantiated, gets its value from the very object that it has been called in. So even though you write this one once, whatever object you are calling this constructor from, this points to that object. All right. Okay. So, okay, there we are. Okay, so we have covered this keyword as well. What do we have next? And there's also this constructor is called, it's a special method, and it's called whenever the object is being created. And there is the special function which is called a destructor, and it's called whenever the object is being deleted from the memory. And you write it like this. Character is called tilde. Okay, and you put the tilde in the beginning of the method definition, and this one becomes a destructor. And what happens is, let me write this one again. So cout hello from the destructor. Okay, what happens is that one is called whenever I'm deleting the student. So this one is going to be called at the very end, you will see. Hello from the destructor, you see, after I have written Tolga 0. All right, this is called the destructor. I believe you already know those. I have asked Ayşe Hoca, and she tells me they are teaching you those at the very end of the BLG 102 course. But nevertheless, I'm going over them once more to make you remind. And if you don't know those, don't worry, it's very easy to learn those. This is not yet object-oriented programming. It's much deeper than that, and you will learn it when you get the course. But you will, you can use those pretty easily whenever you are coding your homework, and I will give all my examples using the classes. Okay, so we have covered constructors and destructors as well. What do we do next? And we do the object initialization. We do the method calls and object referencing. Now we also have something called the copy constructor concept, but I don't know if I should talk about this. Maybe I can talk about this when the time comes. Okay, when we need something, we can talk about the copy constructors and things like this. But right now, these are enough for us to find our way during the course. Now I would like to show you one more thing, which is, now this is pretty much, it gets longer and longer, right? If we do write it like this. So this is a very simple, easy example, toy example, but it's a little bit long. It's not that long, but if I want to do more realistic things, it will get longer and longer. So in order to be more tidy, you want to split your declarations into multiple files. Now we will do this. What I'm going to do is I'm going to get this class definition and the rest, and I'm going to put them in their own definition files. What I would do is I would make a new file called students.cpp, and also I'm going to make a new file in my include folder, which is called student.h. And I have made necessary arrangements in my code editor in order for the code editor to be able to compile these. But I'm going to tell about those in the next lecture, right after the break. So what I will do is first I will fill in the student.h, the header file. And what I will do is I will only put the class definition in here. Okay, so this is my class definition. So when I do this, you see it gets angry to something. What are those? Is this string? It doesn't know the string, so I need to put the libraries for the string in here. Okay, I think that should be sufficient. I don't know if it requires st standard input.h as well, but we will see. Let's see. And what I'm going to do is I am going to put these definitions inside my CPP file. So let me get rid of those and let me put them in here. Of course, in order for this one to know about the student, I need to include that one in here. So what I will do is I'm going to include student.h in here so that it might know about the student, what it does. Okay. And in order for this file to know about the student, I will also include the student.h from here. The rest, the compiler does its magic. So since I have got the header in here, while it's compiling, it will know about the student definition. When it's compiling the student.cpp, it will know about the student definition, and the rest will be the link stage. When it's linking, it will get the student's object, and the main is going to be main object is going to be constructed then by linking the student to it. So let's try and see if it's going to work or not. There is something, student has no get name. There are no get names. Are you sure? No, I think it doesn't. I think I need to put it in here. Let's see. I don't see, but I'm getting these errors.
Hocam,
Yes, Can.
student hash'te using namespace yanlış yazdınız.
Vallahi mı diyorsun? Yes. You are very careful. Okay, I think that one would do. Yes, thank you very much. Okay, we get the same thing. So in order to do this, I have made some modification on the Visual Studio Code backend. Well, I have just set up some build targets, so on and so forth, but I'm going to show them to you, don't worry. Now, this is how to write a class, and we will write a lot of classes during this term. I'm going to give my examples over the classes. And I would also like to, we have a few minutes left, but during that time, I would also like to show you about templates, okay? So this is also a cool thing to have. So let me give you some example of a template. Let me now comment those out. So let's say that we have a max function, okay? So we have two integers, first and integers second. And what we do with this function is if first smaller than or equal to second, return second, else return first. Okay, so what happens if I write cout max 5, 8? I expect it to output 8. Yeah, it works as expected. Now, question, what happens if I send doubles instead of integers? I think there's, oh, there's already a max function. So it's max. Yeah.
Because they should round each other, right?
Yeah, yeah. So let me.
Yeah.
Yeah, they are done. Okay, but what if I wanted to work on doubles as well? So what happened a few minutes ago is there is already a max function defined. So it called the defined max function. So I wasn't able to show you what I wanted to show. So I defined it as maxnum. Now it tries to call my function. And since I'm sending doubles, it gets rounded to the nearest integer, I believe. So, but what if I wanted to work on doubles as well? And also I wanted to work on integers as well, or maybe I wanted to work on characters as well, so on and so forth. What would I do?
You have to use templates.
Yeah. So what you can do is there is some functionality in C++ where you can define we might call a generic functions. So what you do is you write something like this in here. T, okay, and instead of this, you put T in here and T in here. T in here and T in here. And when you are calling the function, you should call it with int or double. Okay, so you say now my function is going to be working with doubles. Now it's working as expected. Okay, so how does that one works is pretty straightforward way. What happens is the compiler looks for your usages. So it counts how many different types that you have used this function. And according to different types that you use this function with, it generates this function that many times. So if I use integer, double, and maybe character, then the compiler, before compiling the code, generates 3 different functions with t's replaced with doubles and integers and characters. And it calls the appropriate generated functions accordingly, which is kind of a straightforward way. It's not very dynamic, but it works. So when you do a definition like this, you can call it for different types. Of course, you need to be careful because we are making a comparison in here. And if your type doesn't support comparison, then you would have trouble. Likewise, you can do the same thing for classes as well. So in here, you can write some kind of a templates type name T. So if you write type name, it only supports the predefined types. And when you do this, actually you can use T instead of whatever you are going to replace it with, and it will work. But I'm leaving those to you now. You can check out the internet. We are going to be using it, so you will have some demonstration when we are using that. Okay. All right, so this is pretty much it about the class. Of course, it's a very superficial and quick overview of classes and objects and so forth. But as we move along during the term, we would have a lot of time to overview those and deal with those. But just I wanted to let you know, these will be the basic tools that we will be using during our demonstration of data structures during this term.